All right, I want to go through the review for test 4. There's kind of two big ideas that I'm kind of looking for on this. So the first idea is, if I give you a scenario, can you tell me what type of problem it is? Tell me the parameters behind it. Basically, can you set it up without actually having to do anything, having to type any numbers in a calculator or a spreadsheet to come up with the probability? So that's kind of what this first part is sort of looking over, is just identifying the vocabulary to figure out what test it is and then what kind of statistic and degrees of freedom it is. The other skill that I'm looking for is this right here, where I'm going to give you some problem and I'm going to kind of give you a hint. In this case, I'm looking for a t-score where there's some degrees of freedom and a p-value. And then I would want you to identify properly whether we'd reject, fail to reject, and if there is or is not evidence based on whatever the null hypothesis is. So that's kind of the two big ideas that I want for this. And I'm going to exclusively use Excel when I do my calculations. But if you know how to type the buttons in your calculator, that's fine. But the idea being that everyone has access to Excel. So hopefully that will make things easier for you. Okay. All right. So first part is going to give you some sort of setup, and then let's talk about what we would look for on something like this. So in number 1, a building inspector believes that the percentage of new construction with serious code violations may be even greater than the previously claimed 7%. She conducts a hypothesis test on 200 new homes and finds 23 with serious code violations. Is this strong evidence against the 0.07 claim? Okay, so the first question is, what type of data are we dealing with? So is this mean data or proportional data? Or is it chi-square data? And then once we figure that out, we'll go within each test. And right here, because there is an expectation of a percent. So whatever data I get, I'm comparing it with the 7%. So we're talking proportion at this point, and I just need to decide whether it's one sample or two. And since they gave me one sample of, let's see, 23 out of the 200, so that definitely is a one proportion test. So according to my little chart here, that would be A. And all proportion tests, be it one sample or two, are all z-scores. And so there are no degrees of freedom for that. Okay. But again, the giveaway here is that 7% was the thing that kind of told me what to pay attention to. All right, number 2, the college ski coach has discovered a new edge modification for skis used in slalom races. It is thought that the new edges will give more control and reduce the time needed to run the race. To test the new edges, a random sample of 5 students ran the slalom twice, once with the new and once with old, once with new. The resulting times were recorded with the data indicated change in times between old and new. Okay, so first thing, let's think about what kind of numbers would I expect to get out of this. Meaning, is it proportion, means, or chi? And we're tracking times, how fast they run a race. So I would expect to get some sort of time data, like a minute 30 seconds or a minute 20 seconds. So it's mean, it's not proportion. And then the other question then, or the next question is it one sample versus two? Well, I'm comparing two sets of times, one with the old edges and one with the new edges. So we're looking at a 2-sample process, which then brings us to, well, is it dependent or independent data? And because it's the same 5 students that ran the same course twice, once with the old and once with the new, that's actually dependent. The time you get for the new edge is going to be related to the time you get with the old edge, right? Same person doing the same race. So this would be a matched pairs test, or a mean of differences test. So that's E on my little chart here. And our test statistic for this, okay, so with mean data, then we have two choices. It's either a t-score or a z-score. And in order for it to be a z-score, I have to know the population standard deviation. They're always going to give me sample standard deviation, but they have to add an additional fact dealing with the population in order to make it a true Z statistic. And in this case, I don't have that. We're just told to compare these two sets of times. So this is a t-score, and degrees of freedom would be sample size minus 1. So since there's 5 students, then sample size minus 1 would be 4 degrees of freedom. All right, number 3, Dan is doing a study of startup costs on small businesses. A random sample of 15 specialty clothing stores had a mean startup cost of $92,000 with a standard deviation of 24. Independent random sample of 12 coffee houses had a mean startup of 74 with a standard deviation of 18. Test to see if this data supports hypothesis startup costs. Okay. All right, so let's go to proportion, mean, or chi. So my data happens to be numbers, dollar amounts actually. So that tells me I'm dealing with mean data. And so am I dealing with one sample or two? And I've got one of the clothing stores and one of the coffee houses. So that means I'm dealing with 2 samples. And are they independent or dependent? And one dead giveaway here is that there's 15 in the first sample and 12 in the second. So it definitely can't be dependent, which means they have to be independent samples. So coming up to my list, it is this right here, difference of means and dependent samples. So for me, I would call that D. Test statistic. I have to, in order for it to be a z-score, I have to be told the population standard deviation. They're always going to include the sample, but I have to have this additional fact. I don't see it, so that makes it a t-score. And last part here, degrees of freedom. Okay, so this is kind of, there's 2 kind of good answers to this question. The first answer is without technology, I would want to base it around the smaller sample size minus 1. So I would say 11, because 12 minus 1 gives me 11. Now, because it is a 2-sample t-test, then I can go ahead and pull out technology and actually get the computer or the calculator to work out the behind-the-scenes formula and actually give me a better degrees of freedom than that. But again, without a calculator, then I can go with sample size minus 1. So let me go pull up this fancy spreadsheet that does this inference procedure for us. Okay, so for a 2-sample t-test, I'm going to go to this one. And I've just got my summary statistics here, so I'm just going to type in these numbers. Let me kind of pull it up in the back here. Let's see. Bear with me a second. Okay. So the first set has a mean of 92,000, standard deviation of 24,000, and an N of 15. And the other one has a mean of 74,000 with a standard deviation of 18 and an N of 12. Okay. Now, I didn't actually write out the hypothesis statement, but that's not really relevant. It's right down here in this spreadsheet. It's already gone ahead and figured out what the degrees of freedom for those 2 samples would be, so 24.9 would be the other acceptable answer. But honestly, 11, I would take 11, or I'd take 24.9, because unless you typed it in the calculator, you would not have gotten that number. All right, number 4, the Magic Dragon Cigarette Company claims their cigarettes contain an average of only 10 milligrams of tar with a standard deviation of 0.16. Random sample of 100 cigarettes shows the average tar content to be 11.5. Is this significantly different than the company's claim? Okay, so let's first start off with means, proportions, or chi-square. The measurement, or what I'm measuring as far as data goes, is the amount of tar in the cigarette. So clearly I'm expecting numbers like 10 or 11.5. So it's definitely a mean analysis. And then I'm given one sample here. So it's some sort of one sample test. So I'm kind of go up which one that was. One sample mean. Okay, so I would say that would be C. Okay, now, is this a T or Z score? And go back to this first sentence here, this very first sentence. Think about what this says. This says that their population, their expectation for all of their cigarettes is 10 milligrams with the standard deviation of 0.16. So is that 0.16 related to the population itself, or is it related to the sample? And actually, if you read on here, they said that in the sample of 100, they have a mean of this, and they don't actually mention a standard deviation. So I would need that. Like if I was going to do any analysis beyond this point, I would have to know in this 100, sample size of 100, what was the standard deviation there, because they didn't tell it to me. So that 0.16 is not related to the 100, it's related to the population expectation. So this actually is a Z-score. This is what I meant by they have to state it. They have to give you this extra fact. And so since it's a Z-score, then there are no degrees of freedom. So I don't have to worry about that part. Number 5, have eating habits changed? 1990, random sample of 100 people surveyed showed that 39 ate red meat twice a week. 1996, an independent sample showed 80 people ate 36 ate red meat twice a week. In this time period has the proportion of people, okay, right there. That phrase, the proportion of. So they want to know, is the fraction or percent changed of what I would expect to see eating meat. So already I know I'm dealing with some sort of proportion test simply because of that wording. Now, how many samples do I have? I've got a sample from 1990 and a sample from 1996. So that puts me at a 2-sample proportion test. So right here, difference of 2 proportions. So for me, that would be B. And all proportions are Z-scores, and I don't have to worry about degrees of freedom when it comes to Z-scores. Number 6, last year the average daily change in the Dow Jones was 7.3 points. Random sample of 15 trading days showed the average change to be 5.2 points with a standard deviation of 10.2. Test the claim that the average change is less this year than last year. Okay, so I have my data as like 5.2, 7.3, so it's some sort of mean data, and I'm only given one sample. So go back up here, one sample mean is C. And that's that procedure. The standard deviation of 10.2 is related to the 15 in the sample. So that's not a population number, that's a sample number. And they didn't give me any expectation for standard deviation of the population. So that actually puts us at a T-score. And so degrees of freedom would be n minus 1. So in this case, 15 minus 1, which is 14.